In this problem, we're asked to complete the square of a quadratic function and then find its vertex. The very first thing we should do is factor out that leading coefficient. So here, if we factor out the negative 2 from all three terms, the very first term we're left with the x squared. Factor out negative 2 from 16x, we get negative 8x, and then from negative 40 we get positive 20. Now, just focusing on what's inside the parentheses, we're going to try to complete the square. Now, the idea is that we want to add on to x squared minus 8x a number such that when we look at those first three terms, we're able to factor this into a perfect square. To find what this number is, you take half of the number in front of the x, so in this case negative 8, half that is negative 4, and then you square it. So we add plus 16. And then we're going to subtract 16 just to guarantee that the resulting function is the same as what we start with. Now those first three terms, by design, can be factored into a perfect square. The number here, the negative 4, will always end up being half of the number in front of the x expression. And then the last two terms combine to give us a positive 4. The last step is to distribute the negative 2 that we initially factored out, distribute that back to both the inside terms, and so we get negative 2 times the quantity x minus 4 squared, leaving the negative 2 on the outside, and then minus 8. And the reason we do this is because in this form, it's in the standard form of a parabola, which means we can identify very quickly what the vertex is. The number being subtracted from x is the x-coordinate of the vertex, so 4, and the number at the end here, negative 8, is the y-coordinate.